How are you guys? Welcome back to my YouTube channel. Uh, Today we'll be dealing with introduction to belt drives in Mechanotechnics N5. In this video, you'll learn how to master your belts, right? If you still remember, you did a little bit of an belt, belt drives previous N, right? N4, you did them. Just was here, there'll be some addition. There'll be some addition things that you're supposed to know. But nevertheless, other things, they are still the same. We still have the same formulas, but there's some spices that they've added actually here because it's N5 level, right? So nevertheless, if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. And then also can feel free to comment and to share this video, right? So here we have given this is a belt drive, which is a V belt. As you can see, V belts there, they've indicated us this is a V belt with using a semi-groove angle. This is a belt. Here we have a pulley. The belt usually is driven by what? By pulley, whereby here on the pulley we'll have the motor that is connected on the pulley there. We'll have the motor. That is how the belts looks like. We have that those are belts, as you can see. Now we have to deal with types of belts here, guys. We have here open belt. As you can see, they say this type of belt is used where both pulleys should rotate in the same direction. As you can see, we know that T2, it's like side. If it's rotating like this, we know the tight side will be about T1. If it was rotating like in this direction opposite, the tight side, if it was rotating like that, if it was rotating like this, the third side was going to be there. You still remember this thing, right? So yeah, we have open drive. What we're supposed to know, we have open drive. That is an open drive, whereby it's a flat drive. Can also be a V belt. We have open belts, we have flat belt and V belts, right? Then that is what we have. 3.1.3 cross belt. We have to let us check here. What do they say? If the driven pulley has to revolve in an opposite direction to that of the wheel pulley, the belt should be cross. Where is however caused by the belt rubbing together. Fine. The efficiency of the belt of the drive is increased through large arc of the belt contact on the pulley. Cross belt drives only apply. Here it's an important thing. Cross check. They say cross belts drive only. Check that way. It's only applies to flat belts. Only applies to flat belt. You understand that? That means as long as if you are given this, if they state this is a cross belt, you must know we're dealing with what? With a flat belt. Must be flat belt, because they've said cross belt only applies to flat belts, drives only flat belts drive. When we're dealing with flat belts, that is where we'll have cross belts. No, here we don't have V belts for cross. No, that is another important note there, right? Another form, the end is indicated this. We'll be looking at two types actually here. We'll be looking at cross and the open belt. We'll be dealing with two. We'll be looking at these cross belts and open belt. whereby we'll be dealing with two types, V belts and flat belt of the two types of belts. So yeah, calculation symbols, you know that power is measured in watts. Type 1, you know that is a tension, it's in Newton. T2 still is a tension, slack is called the slack side, which is it's measured in what, in Newton. Then TC, the effective belt tension in Newton also, is TE, the effective, by TE we know is equal to T1 minus T2, right? So yeah, it still is measured in Newton. TC is a centrifugal force in Newton also. Torque is measured in Newton meter. Um, Velocity of the belt obviously is in meters per second, and the number of speed in it will be rests per minute. Depend if they wanted rests per second, you can calculate. Then the number N, it's a number of V belts or the number of flat belt plies. We'll discuss about plies. This is new to you guys, and we'll discuss about plies and how to calculate V belts, the number of V belts. If we have then those V belt, depend if they give you 3 belts on the number of plies, we'll discuss about them. Then D is a big D. It's the diameter of a driven pulley in meter. D driven diameter of the driven pulley, that one for driving pulley. R driving pulley radius. These are driven pulley. T, we have a thickness, as you know there. We have a thickness, belt thickness. M, the mass. There's no the mass belt pair. You see, they see pair. Must consider that per meter length. That means our length, we must always consider our length as 1. Anywhere where you see in these calculations, when you see L length, substitute it 1 always. Let's say example, you know the volume is equals to what, to area multiplied by what, by length. Under this topic, always substitute your length with 1. Substitute 1 always where you see the length, then you'll be cool. Then volume of the belt per meter length, as you can see, the length. C is what, we pulley shaft center distance, we know. W, the width of the belt. FT, we'll discuss about it. The maximum allowable belt, we'll discuss. Density, it will be given even density this time. Force, coefficient of friction. That B, this is the contractile angle in radians. Then B, the semi-groove angle or V of the V belts, we divide by 2, but it's in degrees. So okay, it's fine, we'll discuss about that. So when you are dealing with some examples, so that you'll see. Then 3.1.5 says formulas. These are formulas. Notes are indicated for belt velocity. How do we calculate belt velocity? Belt velocity, the formulas. Omitted means when removed, if it's no longer there. If it's omitted, if not included, the thickness. If we are omitted, if we are not included the thickness, our velocity will be like this. There will be pi d diameter over n over 6, right? But if we are considering the thickness, we are taking thickness into account, our velocity will be pi. But now here, this T plus thickness, we call this effective diameter. So we will use effective diameter, whereby effective diameter is equal to, it will be diameter plus thickness. Do not forget to add the thickness, divide by 60. Then C, this is what is how you get the speeds. Remember, this is the speed when you are matching 2 gears. This happens only when we are matching 2 gears. Yeah, we understand that it's a gear ratio, that one, when you're matching gears. Then they say we have seen that now. Okay, I am here now. I'll come to this direction. We'll come here. Let me just be here. I2, there is, you have given the tension T1 and T2. How do we calculate them? here is the formula for flat belt. As you can see, for flat belt node, there is T1 over T2 is equal to E raised to the power of coefficient of friction multiplied by the angle of contact, like that we'll see. But if you're dealing with V belts, we're considering what? Look at that, the different level have what? Cosec beta, whereby that is the same as 1 over sine beta. This is cosec is same as that. So we'll see when we're dealing with this, whereby someone can write this as like right into multiplied by 1 over sine beta. So yeah, for V belt, effective belt tension is here is T1 over T2 minus T1 minus T2. So our initial tension, how to find the initial, this is often used there when we found this thing, initial tension, when you're dealing with what, the loads sort of stuff. Most of this equation will use it when the bearing, if I remember, when we have that. Okay, the initial tension nevertheless is given by this formula, guys. It will be 2T initial, it's O, be T1 plus T2. That is how you calculate your initial tension. Then you make initial tension the subject. If you make initial, this 0 represent initial, then it will be T1 plus T2 divided by 2. This is how you get your initial tension. If they will ask you for initial tension, that is an important formula there, as you can see, guys. Then we have our centrifugal tension. Centrifugal tension, which is denoted by TC there. We have a small c there. So if we're dealing with flat belts, if we're given flat belts, as you can see, we'll have T1 minus TC over T2 minus TC into that E raised to the power of U coefficient of that. We know this, but now we'll differ. If we have a V belts, we'll consider the angle of groove, whereby we multiply that, difference will be there, the cosec there. We'll consider the angle of groove. This side, the left hand side, will remain the same, but the right hand side will differ with what? Cosecant. We'll have that. You see the cosecant part there, considering the V groove, the semi groove angle there. So yeah, but however, TC by its own, this TC by its own is calculated by what? Mass into V what squared, whereby we know this, it's simply just a velocity. It's a velocity of the given that pool of belt. So note, they say note for belt speeds exceeding, this is important, exceeding 12. But however, guys, you'll be considering when exceeding what? 10. When exceeding 10 meters per second, when you will start from 10. When exceeding, let us start here, we'll start from 10. Take note about what I've given. When exceeding, if the speed is greater than, if you're using in maths, is exceeding centrifugal tension. You see, exceeding centrifugal tension must be considered. If the speed is greater than 10, we have to consider, we must calculate the centrifugal force, TC. We must calculate it. You understand? As long your speed, if you calculate the speed there, you're supposed to check the speed always. If you get your speed that is greater than 10, if your speed is greater than 10 meters per second, you have to calculate TC. Consider TC always. So yeah, start from 10, guys. I assure you, we'll start from 10, not 12, but start from 10. Then if your speed is less than 10 meters per second, the effect of centrifugal tension is negligible, unless guys, unless if the question written, please may you consider TC. If it's given, consider centrifugal force. There's nothing you can do unless if they've given us direct, but in the natural form or in the like logically, so we're supposed to neglect it if it's less than 10 meters per second if the velocity. But however, if the examiners say consider it, even if it is like that, then there's nothing you can do. Let's simply just consider it. But take the note, if your velocity is greater than 10 meters per second, always consider TC, your centrifugal force, right? So IV belts mass, I've given mass will be volume per meter length multiplied by density. Here it is. Belt cross-sectional area, meter length, density. As you can see, the mass, if you want the mass of the belt, must be equals to volume multiplied by what? By area, or no, volume multiplied by what? By the density. Let me say like this, density. This is what, but however, we know volume is equal to what? To area multiplied by what? By length. Remember the volume, right? So we must understand that. But still we have what? The density there. If we include the density, let's say if we include in the density now, where is no longer volume, will be what? Will be calculating mass. And also you must know that area, the area by its own will be width multiplied by what? By the thickness. If we are given the thickness, then the area is width multiplied by what? By thickness multiplied by length multiplied by density, which is our mass. But remember, I said to you guys, L, always substitute it 1, write it as 1, must be 1. Consider it as a per meter. As you can see here, per there, per meter length. Take it as 1. Substitute 1 where you see that. So yeah, guys, then now here we'll be considering the belt length, how to calculate the belt length for open drive. As here we have given the diagram here for open drive. The belt length, here again, the belt length, here we have some new formula here. As you can see, for open drive is this one. Yeah, but you can use the old one if you want. Will be pi multiplied by r plus r, small letter r, this is the outer pulley, small pulley radius, plus 2 into the square root r minus r squared plus c squared. So yeah, this is the formula. You'll see this on your textbook there to calculate the length. But do not forget to use the one. You can also use the one that you have learned, N4. Remember on your previous N, we did learn about to calculate the length, whereby is this typical formula. Where is that typical formula? Is this one. You still remember? You can use this either way if you like. Still fine. You can use this too either way if you like. So then for cross belt, remember for cross belt will be different thing now. Here we'll have what? Positive. The difference will be here. Will be now here we're having positive. On this one we're having what? Minus. The difference is only there. There cross must be plus. Open belt must be minus. So yeah, you can also use this formula. Yeah. The difference also is just here. There is minus, here is positive. So yeah, you're good to go there, but it will be given on your formula sheet. Either way, the angle of contact, note calculating, theta is always in radians. This is always in radians. As you can see, it's always in radians. So yeah, the angle of contact we have given there, theta. To convert this, if you are given 18 degrees, you'll divide it by what? By 57.3, or you can use this format. But the easy one is this one, guys. Let's say you're given angle theta to become is 50 degrees. When you'll just, if you want this to be in radians, will be 50 divided by 57.3. Then you are converted. When you convert, this will be in radians. So that is what you're supposed to know there, guys. So far, sorry about that alarm, sorry about that noise. So as you can see, this is an open drive. That is how we've given our open drive crash there. Then C is a center distance, the distance between the pole. We've discussed about this N4 level center distance. We know the center distance. So yeah, now we have this formula, okay? We have this formula now for cross belt. Let me zoom out a bit like this. Hopefully you still see. I want to zoom out a little bit like this so that you see something here. This, guys, is for cross belts. Okay, no, it's an open belt. As you can see, these guys, they've said this is an open belt. We are focusing on this structure now. Right, that is what we're given, open drive. As you can see here, we have theta on the small pulley. If you can check here, we have theta, that is written theta 1. As you can see there, we have theta 1. There we have theta 2, and then as you can see, theta 1 is there. That arrow shows is like that. As you can see, we have given those theta 1, theta 2. Take a note there. Now, how to calculate the angle of contact. I want you to see how to calculate the angle of contact. Remember now is theta. To calculate the angle of contact, if you have given those pulleys, if you have given these, for the small pulley will be what? Theta 1. Here's the formula that we are using. Sine, you'd have this sine to be equals to that, right? After getting this value, actually this was supposed to be, will be replaced by that angle, the phi will be equals to theta 1, whereby is equal to 180 minus 2 phi. We'll get it there, the phi. That is how the phi there, we'll get it from this. Then the second one, how we will replace this phi, you're supposed to take it from there. The angle phi, you'll get this angle from this equation. Then you take it and then you substitute there, depending on what you want. Yeah, so yeah, if theta 2 is for big pulley, will be 180 plus this. The difference is like that. Yeah, I love to use this one, or you can also use this, but I love to use this one. Either way, guys, depend, choose which one you use. You're using this or you're using that, as long as you not forget there, guys, this formula. But as you practice, we'll put this formula into work. You will see what is going on. So cross belts, as you can see, we've given now cross belts. You will still have theta 1 on the small pulley, theta 2 on the big pulley. So here, check the notice. Here we'll have plus, isn't it? Then check the difference. When it's open, we'll have minus. Do not make a mistake about that. Yeah, here we have minus. These are radius of the big pulley, radius of the small pulley. divided by the center distance. So here on the cross belt, theta 1 is equal to theta 2, whereby will be equal to 180 degrees plus 2 alpha. This is simply like this, or you can take this path if you want, but here is the easiest. Simply just go straight to your answer. This is the same, the angle of contact there is the same through each pulley. Then now we want the belt. Let's check now. Let me zoom in a bit. Sorry. Yes. Yeah. Now I want the belt width. The belt width will be given. This is T1. Tight tension is tight tension. Leg belt or tight belt there. Tight side, tight side. Leg, like those things will be T1 tension there. Will be equals to width. This is width multiplied by thickness. The allowable tension, what this is. The FT will depend, guys, what you are given. Sometimes will be per pliers. What sort about that? Will be tension. Will be tension per plier. Most will be also will be Newton per plier. Will be millimeters per plier. Will depend. You will see here, as we are doing some examples, you will see then T1 is width again. This is the number of plier and that allowable tension. Then the number of plier is equal to T1 over maximum allowable tension of the belt. So we'll see N, it's a number of plier. It must be number of, it depends. N is can be number of pliers, or can be number of what? Of V belts. If you're dealing with V belts, if it's a V belt, N will be for the number of V belts. But if you're dealing with a flat belt will be the number of pliers. Remember, flat belts has no number of V belts, but has the number of pliers. Also, V belts, they don't have the number of pliers, they have V belts. So the number of belts, you understand? So yeah, then these are formulas to calculate power. As you can see, this is the famous one that you know, guys. Yeah, this is simply effective tension multiplied by V. Then, but we know that the velocity is like this. As you expand the velocity, there if you are given thickness, if you are considering thickness, is considered, we'll have plus T. Thickness is omitted. There we'll have like that. Here we are considering thickness on our velocity. Then you'll see V belts, we have some new equations here. We'll see T1 into 1 minus like that. You'll see as we are dealing V belts, as you can see, if we are considering the minus that, if we are considering the centrifugal force, tension, or centrifugal what there. So centrifugal tension, if we're considering it, centrifugal force there on the tension. Then there's this other one, as you can see, but this is for V groove. If you see cosecant bit applies only on V belts, this will take place only on V belts because B is a semi-groove angle. Then yeah, must be in meter. You divide by 2 that angle, so that you put the here we had, if we include TC into account, we'll have that. So these formulas, guys, you'll see when we're doing some more equation. You just have to subscribe there so that you'll be notified as I'll be posting videos on this topic right around this module. So I've given 3.1.6 calculations. We've given example 1. this is a preview, guys. Preview, or you can say this is a revision. You understand, that is a revision, guys, just a preview. The example 1, what does it say? May I please change the white color? I want to make it black. So okay, thank you, guys. So a flat belt drives consist of a flat belt drives consist of 200 millimeter diameter driving pulley, that is for driving pulley, and 100 millimeter diameter driven pulley. Determine the driven pulley speed if the driving pulley rotated that. So you see how the cookie crumbles there. If you have given this is just the basic one. We know that we have this formula d1, you remember, is equals to the speed of the pulley 1, pulley 2 multiplied by the speed of pulley 2. This is taken in relation to this formula t1 multiplied by, you remember most, t1 multiplied by np when n1, t2 multiplied by n2. You still remember when you have given the matching gears, but now we have given the pulleys. You understand, if you are given the pulleys like this, we'll use this, right? So if you are given the gears, you use that one of the teeth. So yeah, so diameter 1 you've given them, we want n2, so the speed 2, want n2 there. For the, say we should calculate the driven pulley is the one that is driven. We make n2 the subject, will be d1 into d1 divided by what, d2. Then now it's a matter of substituting, isn't it? So we have that d1, obviously it was 200 millimeter. You can convert to be in meter, but why do not convert? Remember, as long your SI units throughout are the same, there is no need for you to calculate to convert if they are the same. But if they are not the same, please use meters so that you won't make some mistakes there. 200 multiplied by n1, which you have given here. They say it is 700 and what, and 50. Rotate to 750. Remember this, I substituted this as rest per mean. That means this one also will be in rest per mean as our n2, because I used that in rest per mean. Divide by diameter of the d2 of the driven, which is 100 millimeter. This would be 100. So why use, even if you have a millimeter of a millimeter, will simply cancel, so there's no need to convert there. Hopefully you understand. If you punch that, you'll get 1500 rels, must be in rels per minute, because I've used this in revs per minute. So yeah, this is what our n2, this is a basic, it's just a preview to remember. So this is how we go, guys. Here, can I project the question for you? Yeah, example, I have example 2 here. Example 2, let me just say this, or I can say example 3 like this there. And let us see how does it read. The says the thickness of a belt is 7. This is what it is, a thickness is equal to 7 millimeter, and the width of the belt, the width w, the width is what, is 150 millimeter. If the density of the belt is we have given the density, or you can say raw, is up to you, but it's one and the same thing. Raw and density I'll use like that to not, this is 1 not comma, sorry, 1 times 10 to the power of 3 kilograms per cubic, right? Is what we have there. They say we should calculate, then calculate the belt mass. They want the belt mass. As you can see there, the belt mass. I've discussed about this, guys. The belt mass per unit length. Per unit length. Remember, I will say we'll consider the length as 1 under this belt. Always take the length as 1, guys. If you are calculating a mass, or please use 1. Use 1 when you see. So we want the mass. We have discussed about that formula for the mass, isn't it? We know that we said mass is equal to volume multiplied by what? By the is volume multiplied by what? Density. Or you can say raw if you want, or you can use only P as long you know that it will be density. Density, or you can use it in words. I can use it volume multiplied by density. Then we know that the volume, what is volume? Volume, I said the volume is what, guys? It's an area. We know it's area multiplied by what? By the length, right? This multiply, we have the density there, right? But the area, I said the area by its own area is calculated by what? Its width multiplied by thickness, that is area. We have this is area, but we also have what now? Our length there multiplied by the length, and our density there, then multiplied by our density. So this is what actually the mass. So we've given the width. Check, we've given the width, so which is in milli. Check the length, they said per unit length, which by which unit length, which is in meter. So must convert everything here. Must convert this, you must divide that by 1000. Supposed to get your thickness to be what? 0,007 meter. Divide this by 1000 also, you get this to be 0,15 meter. Yeah, this is the convection. So we can substitute our thing width. It was, see, it is 0,15 multiplied by the thickness. If see, we have converted it, the thickness 0,007 meter, or 0,007 multiplied by the length. The length, I said always put 1. Per length must be 1. Then we substitute our density. It's here, it's our density, 1 times 10 to the power of, okay, 1 times 10 to the power of, to the positive, to the power of positive 3. Then now you can get your Mr. Mass here by projecting this on your calculator, by calculating this. Then our mass will be 1,05 over here, it's in kgs. But remember, per must be per meter length. Remember, you used liter per meter length. Per meter length. Kg will be like this. The mass here will be that per meter. Well, remember, when you say per meter, that means you've used the length must be per 0.5 kg per meter, because we've used our length as meter. We've considered the length. We've considered the length to be what? 1 meter per. So far this is what you're supposed to know, guys, in this video. And thank you for watching, guys. Thank you for watching. Thank you for watching. Since you've given this, okay, we can calculate, but nevertheless, thank you for watching, guys. I wanted us to calculate, but we'll do on the next coming video, no, next coming section. Please, and please, guys, please, ladies and gents, please subscribe there. Subscribe if you have not subscribed to my YouTube channel, please, so that will help me to bring more videos like this content. So guys, if you like, you give me spirit to post more. Thank you, guys. You can share this video to your fellow classmates. You can comment and like. Thank you for watching. All the best.